Okay.
Sir, good evening, sir. Ramaseshu garu. Good evening, Andy.
Good evening.
Good evening. Sir, shall we start, sir?
Yeah, I can start. Yeah, I'll
Okay.
start. Shall I say the?
Just 1 minute, sir. Okay.
Okay.
So,
Sir, good evening at Ramaseshu garu. Chandrasekhar sir.
Good evening, Bhavnara.
Warangal sir. Sir.
Nice, nice.
Sir.
Voice
Sir,
okay
sir.
na? Voice మరి
Voice okay sir.
voice
Baanu,
ban
sir.
on, sir.
Okay, okay, nice, nice.
So, good evening to one and all. It is my privilege to introduce my teacher and my MTech thesis guide, Dr. D. Ramaseshu garu. Now, Dr. D. Ramaseshu garu is working as a professor in Civil Engineering Department, National Institute of Technology, Warangal. He obtained BE from OU College of Engineering, Hyderabad in 1985 and ME from Indian Institute of Science, Bangalore, IISc Bangalore in 1987 and PhD from NIT Warangal in 1995. So Ramshesh Garu has joined REC Warangal in 1990 after working for 3 years in KITS Warangal. He has more than 35 years of teaching and research experience. He taught several courses at BTech and MTech levels with a good practice of sharing latest practical information. So Professor Ramshesh Garu has 5 patents that is granted. So in the field of concrete materials and structures, he has guided more than 100 PhD dissertation works and supervised more number of PhDs in the field of structural engineering. He has more than 135 research publications to his credit in international national journals and conferences of repute related to the concrete materials and structure. He has carried out several consultancies also. Professor Ramjesh Garu has received Outstanding Concrete Engineer Award for the year 2023 from the Indian Concrete Institute, Ultratech Warangal, Telangana State. He has an alternate member of Bureau of Indian Standards and said 2.2 concrete subcommittee representing NIT Warangal, member of IRC B5, steel and composite committee, fellow member of Institution of Engineers and member of Indian Concrete Institute and Indian Society for Technical Education. He is a reviewer for International Journal of Structural Engineering and Mechanics Korea, ASCE Materials and Materials, member BOS and Research Advisory Board of several universities. Sir, this is the brief profile of the Dr. D. Ramjesh Garu. Now I hand over to this session to the Dr. D. Ramjesh Garu. Sir.
Okay. So, good evening, everybody. So, first of all, let me thank the Mapatla Engineering College for organizing this Atal MTP program and giving me a chance to interact with you all. So today, my topic will be on the health monitoring of the concrete structures using non-destructive testing. You all know, at least to some extent, what is non-destructive testing. So just see what are the various. Hello. Are you able to see the presentation?
Yes, sir.
Oh, okay. Right. So you all know about what is this non-destructive testing all about, and how it is useful, and what are the various techniques that are helpful in the monitoring of the health of the structures. So this is what briefly what is the topic today. Okay. Let me go into my presentation. Now, coming to the health monitoring of concrete structures, we'll just start with a very known topic. All of us, we have studied about the limit state design, limit state of collapse and limit state of serviceability. These are the things we have already studied. So limit state of collapse means the structure must be safe. It is for the society for which demands the security in the structures it will handle. That means the collapse deals with the aspect of the strength aspect, whereas the serviceability aspect deals with the performance of the structure, particularly certain aspects like deflection, vibration, cracking, etc. So these are the two aspects that must be fulfilled in any design. Now, so in case of the structures, there are three aims normally. One is the proper design, first one. Then second one is a proper execution. And the third one is a proper maintenance. How do you check the proper design? Proper design means somebody will design and somebody is going to vet the design or proof check the design, etc. These are the ways in which we can see whether the design is proper or not. Then when it comes to the execution, we conduct several tests during the execution. For example, if it is a concrete, we cast the cubes and try to assess what is the strength of the structure, etc. Different material testing we carry out during the part of the execution. Then coming to the proper maintenance, how do you ensure proper maintenance? First of all, okay. Proper maintenance will be assured by the process of condition assessment of a structure. That's what we call this condition assessment or structural health monitoring. So these are the three aspects for the successful implementation of the structure. Now, but in the recent times, there is an increased awareness of the performance-based design, which calls for the action by the forensic engineers. So this particular action, which is based on the performance, is called the structural condition assessment or structural health monitoring. Okay. Now, coming to this SHM, briefly it is called SHM, that is structural health monitoring, which is nothing but it's a process of implementing a distress or a damage detection strategy for all types of engineering structures. Then this is very helpful and it serves as an alarm system for controlling the distress or preventing the failures. So when we can assess what is the current status of the structure, then we can take certain measures to prevent any unforeseen distresses, etc. So this particular SHM is the process involves a logical examination of the structure to identify a particular cause of the distress, if any. Then when it comes to the examination it starts from visual inspection, and we check the documents, the drawings, construction records, etc. And the determination of the time of appearance of the defect and analyzing the test reports. So this is the process that involves the structural health monitoring process. Now, in order to have a better understanding of this structural health monitoring, we can have an analogy between the medical doctor and SHM. So you can see this particular slide, which will explain you the similarities between the process the medical doctor does and what the process done by the SHM. For example, if you see the medical doctor, he monitors the patient. And when it comes to SHM, he monitors the condition of the structure. Then in case of medical field, medical doctors, whenever the patients, depending upon patient's health, if necessary, the doctor prescribes certain medical treatment, medicines, and things, and he prescribes the ultimately corrective medicine if required. Similarly, in structural health monitoring also, the engineer uses certain types of sensors. Mostly the sensors are of non-destructive waste to check the overall structure. So if there is any fault or if there is any excessive stress or deformation, etc., which is the result of this entity, then we'll try to correct the situation by adopting proper rehabilitation techniques or reprogramming techniques. So this is what the analogy between a medical doctor and a SHM engineer, structural health monitoring. Now, then what is the critical requirement of this correct condition assessment? So critical requirement here is open-minded approach. You should go to the field with an open mind. Don't have a prejudiced mind. That means prejudiced mind means suppose if there is a crack, don't think that the crack is due to certain load. Cracks can be due to the non-structural cracks also, etc. So that is why you should inspect the structure with an open-minded approach. Then only you will come to a correct conclusion. For example, I'll show you one particular picture like this. You are seeing the first one is a bridge supporting system. Then the second figure, you are seeing a precast girder. If you look at the type of cracking in these two structures, type of cracking is looks to be very similar. Actually. Then don't conclude that the cracking is due to similar cause of the same cause behind this crack, because the cracking can result due to several reasons. So you see the cause of the cracking. In case of the bridge supporting system, that is the piers or something like that, the cracking ultimately it was found to be due to the alkali-silica reaction. That means the alkalis that are present in the cement, they react with the aggregates, reactive type of aggregates actually. Then in the presence of moisture, the alkali-silica reaction takes place, then causes the expansion of the system and it leads to cracking, which results in a map type cracking. Map type means it's episodic cracking like this. Okay. But the second picture you see, that girder is a precast girder. Precast girders normally they are cured at high temperature curing, accelerated curing. So what happens when this accelerated curing is improper? That means temperatures are higher than let us say 60 degrees centigrade, etc. So what happens is there is a delayed formation of the ettringate. You know what do you mean by ettringate? Ettringate is the result of the reaction between dry calcium aluminate, that is the product that releases in the form of in the presence of hydration of cement water. Then calcium sulfate. Calcium sulfate normally that is present in the gypsum. Normally gypsum is added to control the hydration reaction. So in the presence of high temperature curing, what happens? There is a delayed formation of this ettringate. When there is a delayed formation of the ettringate, that means during the process of curing, that is high temperature situation, this whatever the ettringate form that gets dissolved actually. Then when the precast that beam structure when it cools down, then again ettringate tries to form it. So by then already the system has hardened to some extent. Then in that hardened process, hardened structure, when there is a ettringate formation, that is expansive in nature. Naturally, it leads to the crack. So that is why just by seeing the crack pattern, you cannot conclude that the causes are similar. So you should have a thorough investigation, then come to the conclusion that such and such is the reason for the cracking. So that's why I told you any testing, it requires the open-minded approach. Okay. Now coming to the causes of distress or failures. There can be several causes of the distress or failures. Here I have listed a few things. One is default maintenance. For example, unsatisfactory inspection and monitoring of the existing infrastructure, design execution flaws, then material failures, that is corrosion of the conventional steel, reinforcement within the concrete, overall deterioration, sometimes overloading, that is increased loads or design requirement over time, that also causes a crack. Sometimes the reasons are unknown, we attribute it to unknown phenomena. So the cracking can be due to several factors, combination of different factors also. So sometimes the failures are sudden or catastrophic. Some failures, they take a long time to show. Now let us see. When it comes to structural health monitoring, this structural health monitoring has several categories. Categories we can say static, starting from static field testing, dynamic field testing, periodic monitoring, continuous monitoring, etc. And here we have got different levels of essential, starting from level 1, level 2, 3, 4, etc. Level 1 is the lowest level. Level 1 means with the help of some kind of instrumentation, we detect the presence of damage, but we do not know where is the location of the damage. We say that there is a damage is present, but where is the damage? That location of the damage is determined in case of level 2. In case of level 2, we detect the presence as well as the location of the damage. Then what is the severity of the damage, how dangerous the damage, etc. That is done in level 3. Level 3 level of inspection, in that we try to detect the presence, location, as well as the severity of the damage. And when it comes to level 4, consequences of damage, it's not only presence, location, and severity, but the consequences of the damage, they are elaborated in the level 4 kind of systems. So as these level increases 1 to 4, the system requirements increases. At the same time, the cost of the inspection also increases. Now coming to the different kinds of components or accessories that are required for this structural health monitoring, that includes starting from the sensors. First of all, sensors, they are actually installed on the structures. The sensors mostly the non-distributed pin sensors, okay, and they will extract the data from the structure, and that will be fed to the data acquisition system, and that will be transferred to the analyzing station, where the data is analyzed and try to determine what is the process, what is the status of the structure, etc. So it involves several components. Let us try to see different types of components that normally use in case of structural health monitoring. And it depends upon, the instrument depends upon the parameter that you are trying to investigate. Suppose if you are trying to investigate load effects, then you should have a instrumentation that can measure the loads. If you are interested in deformation, you should have a instrumentation that can measure the deformation. Like that, it depends upon what parameter that you are investigating. For example, if it is load, we try to install the load cells. Normally, load cells, they can sense the type of the magnitude of the load. And from this, what is that we try to assess? What is that we try to assess? Whether the loads that are currently acting on the structure, whether they are as expected or not, or whether they are within the design limits or not. how the load distribution is there, whether they are as per the design, etc. So these are all the things that we try to assess in case of load monitoring. Next is apart from the load, we try to assess the deformation. Deformations, like deflections, anything. Okay. Deflections, we try to use the different types of instruments, starting from a simple instrument like dial gauge, then length gauges, then transducers we use to determine the deformation. Whether there is an excessive or deformation or unexpected deformation, etc. Whether the deformations are also as per the design. As per the design, structure is supposed to experience certain deformation. Whether those deformations which are currently in the structures, whether they are as per the design or not, etc., or whether they are exceeding certain limits. Then, apart from load and deformation, sometimes we try to assess the strain also. Strains, that is intensity of the deformation. So here we normally employ the strain gauges. The strain gauges are fiber optic sensors. We try to use this. Normally, the strain gauges, they are attached to the parts where we are interested to find strain. For example, the steel reinforcement. Suppose the steel reinforcement is present in RC, then we try to embed this strain gauges, and strain gauges are attached to the steel reinforcement. So whenever due to the load effects, when the steel undergoes deformation or strains, that can be assessed through the measurement of the strains. Then apart from this load deformation strain, then we also try to monitor what is the temperature also. Sometimes the temperature conditions will accelerate the deterioration process. Actually. Certain deterioration process, they get accelerated in the presence of ambient temperatures or convenient type of temperatures. Okay, so that is why there is a requirement for monitoring the temperature. Normally, we use simple infrared thermometers, or we use the infrared thermography techniques to monitor the surface temperatures, etc. Then, apart from this deformation, strain, temperature, we also try to measure the acceleration. So normally, in case of vibrating equipments, vibration, for example, suppose in a structures which are located in the where there is a possible vibration. For example, mining activity is going on nearby the buildings, then definitely the mines, the extraction of the coal, etc., they involve small kind of blasting, etc. And these blasts, they induce certain type of vibration. And when these vibrations transferred to the structures, they also undergo this vibration or acceleration. And if they are well within the limits, it's okay. Otherwise, the structures are going to show up correctly. So to measure such kind of acceleration, we use accelerometers. Accelerometers, they can be installed on the structures wherever we want, and we can measure the intensity of accelerations. Then sometimes the wind speed, apart from this acceleration, temperature, etc., the wind speed is a normal thing that we are interested in measuring to know the effects of on these structures. So wind loads can govern the design of a long span bridges, all buildings, etc. So in such cases, they try to record the speed and pressure of this wind at various locations. Normally, this is wind pressures are measured, wind speeds are measured by anemometers. They install the anemometers and try to measure the speed. Okay. But nowadays, the digital equipments have come. They handheld instruments. They can measure the instantaneous the wind speed, etc., in that particular location. Then, apart from this load deformation, temperature, strain, etc., acceleration, we also measure acoustic emissions. acoustic emissions. So we'll see in the presentation what is acoustic emission normally. Normally, in the structural health monitoring, this acoustic emission technique is very well employed actually, and very useful technique also in this. That means in this acoustic emissions, whatever the acoustic signals that are released by the structure, when the structure releases the acoustic signal, whenever the structure is loaded, definitely it releases the acoustic signals. Then these acoustic signals will, the pattern of the acoustic signals will convey what is the status of what is the structural health of the structure. Okay. So this is also one kind of a measurement that we resort in case of a structural health. So these are all the various, in all this process, various NDT equipments are employed. Okay. Now let us see. Of course, this slide shows you what is the brief about what do you mean by testing. Actually, this is a general slide actually. They need to evaluate the existing structures. Arises because of these several situations. For example, if you want to rehabilitate a structure, you need to know what is the existing condition of the structure. Whenever there is a changes in the occupants of the structure, then also there is a need to assess what is the status of the structure. For example, in a particular building, if it is used for, let us say, for a classrooms, etc., it has got certain kind of loading. Suppose when the organization decides to use that building, convert into a laboratory, let us say, where then they want to install particular equipment, particular machine on that particular floor, then definitely the building needs to be checked for its changes in this use occupancy. Then similarly, whenever drawings are not commonly not available, lost over the time on changes in the ownership, etc., then also we need to go for the testing. For example, normally the testing is also required whenever we try to apply the building codes. Then also we need to go for testing. We need to assess the condition of the structure. What do you mean by applying building codes? For example, if you see the IS 1893 code of practice, all of you know IS 1893 code of practice, that is for the earthquake resistant design. In that, you will find the zoning map actually, where India is divided into certain number of zones. Earlier, 1984 code of practice, the IS 1893, the India was divided into the zone 1, 2, 3, 4, 5 zones actually. Okay, so depending on severity, zone 1 is normally very less intensity from the point of view earthquake activity. That is considered to be the safest zone. Normally, Deccan Plateau, that is Hyderabad region, all these things, they used to come under zone 1 actually. But after the revision in 2002, they have merged this zone 1 into zone 2. They have merged zone 1 into zone 2. That means there is no zone 1 actually. So then what is the effects? What happens to the buildings which were designed based assuming that the location is in the zone 1? Now that code has changed, elevated the zone 2. Then in such case, we need to assess the condition of the structure, whether the building is suitable for the zone 2 condition. Already existing building is existing, which were designed for zone 1, but now that code has changed. In order to apply the new code, compliance of the new code, we need to assess the building status actually. So then also we need a kind of a testing. We cannot disturb the building. We need to go for the NDT, non-destructive testing. So this is what the different situations where we require the different kind of testing. So the testings are of different types. One is destructive type, then partially non-destructive, and completely non-destructive type. Non-destructive means so wherein we don't create any kind of a damage to the system. So the actually concept of NDT is not a new one. Concept of NDT is as old as human civilization, almost. So you see how, for example, if you remember how our ancestors even today, how you test whether the mud pot, where you store the water in summer, how do you test the mud pot whether it is crack free or not? You just see lighting, etc. You can find where any cracks are there. Suppose how do you find when you go for the purchase of any fruits, mango particularly? How do you test whether the mango is okay or not without cutting or eating? Okay. So then smell. You just look at the color, smell, etc. Then you will find the mango is okay. So such things are all non-destructive testings actually. Okay. But nowadays, because of the advent of the technology, we have got several instrumentation which is available, okay, which can detect the several kinds of signals. We are now employing those instruments to find the condition of systems, condition of structures. That is non-destructive. So that's why non-destructive testing uses a wide variety of analysis techniques which are developed in science and technology, science and industry to evaluate the properties of the material component of the system without causing damage. That's the primary thing. So NDT does not permanently alter the article. It's a highly valuable technique which can save both money and time in terms of that in product evaluations. So there are advantages, definitely there are advantages. So we can have a better investigations, more number of investigations, then rapid accumulation of the data, generally uses less expensive than destructive testing, then minimize the interruption of the building services. So while being testing, we can use the building normally as usual. So there is no interruption of the building services actually. So these are all the advantages actually. But apart from the advantages, one should be aware of the disadvantages also. So what are the disadvantages? Disadvantages means you require more than one test method. Test method means here independent test method. The test is not dependent upon the other test. We should come to a conclusion by conducting at least two tests, at least. You cannot conclude just by conducting one test, you cannot conclude the status of the structure. At least you require another independent test to confirm the result of the first one, interpretation of the first one. So that's why more than one test method is required. So that's not a disadvantage, but it is a necessity. Then sometimes the environmental and field conditions will affect or distort the results. And sometimes the construction details, that means presence of the reinforcement, the structure, etc., they also affect the results. And sometimes we cannot determine the reasonable degree of accuracy without the destructive testing. So there are certain disadvantages, but however, with the development of the technology and availability of new kind of instrumentation, people are able to conduct the NDT investigations very easily. Here, I have listed certain NDT methods. A few of the NDT methods, the list is very big one, but however, I have listed a few things actually, starting from visual inspection, half cell electric potential method, rebound hammer test, carbonation, permeability, and penetration resistancy, cover meter, radiographic testing, ultrasonic pulse velocity testing, then sonic methods, ultrasonic methods, impact echo testings, GPR, ground penetrating radar, then radiographic testing, infrared thermographic testing. There are the list is goes on like this. But we try to discuss these things in brief, how it can be used for evaluating the different parameters of the concrete, particularly with reference to the concrete and steel. Okay. Now let us see NDT methods. So this slide is a very general slide. Visual inspection. Starting from the first and foremost thing that is required is a visual inspection. Visual inspection helps us whether actually is there a need to go for a testing or not. Or if the entire damage is visible, there is no need to use any instrumentation. Okay. With the visual inspection itself, we can tell about the condition of the structure. Okay. So understand the visual inspection means what is the scope of this visual inspection. As a part of visual inspection, we first try to understand the structural layout or structural system. Where are the critical components, critical areas for the inspection? Where is the possibility of the critical, possibility of the stresses, etc. Similarly, identify the allowable imposed loads in order to assess the usage and possibility of the overload. Then we can also assess whether there is an unauthorized addition or alteration of the building. Suppose as per the design and planning, the building is something like that. But while constructing or in course of time, they might have altered certain things. So those alterations also may affect the loading patterns. So these things are all we can assess as a part of visual inspection. So visual inspection is a precursor to any kind of a testing. It's like a reconnaissance. In survey, we call the term as a reconnaissance. Okay. So now, this is the first visual inspection. So in the visual inspection, what types of, what is the kind of instruments that normally is used? It is as simple as some small scales, hammers, cameras, magnifying glasses, etc. These are all these small instruments we use, chisel, hammer, etc. Then to robotic based instrument, robotic crawlers. We use the robotic crawlers, which will send them into the hazardous areas. Hazardous areas, first of all, this robotic crawler will go and take the pictures, and then after observing these pictures, then only the inspector will enter into those the hazardous zones actually. Okay. By taking all proper measure care. So this visual inspection involves the portable video inspection that allows the zoom, etc. So these are all the things as a part of visual inspection. Now, certain defects which are normally found by visual inspection itself. For example, you can see in this particular slide, erosion of the brick face is a visual actually, or efflorescence, that is formation of a lime spots on the brick face, or even on the plastered surface, you can see. Then bricks falling or some kind of a delamination. You can see the delamination. Okay. Then cracking in a wall. That's a visible. In a wall or a concrete, you can see visually. Doesn't require much instrumentation. Similar delamination, concrete cover. These are all the certain things which we can, certain defects which we can find by visual inspection. Okay. There are some simple techniques are also there which will give us an idea of the status of the structure. For example, hammer sounding technique, hammer sounding techniques. This is a qualitative evaluation. It's not a quantitative, kind of a qualitative evaluation of the concrete system. Okay. Suppose, for example, when you take the hammer and struck on a concrete surface. If the concrete is good, it gives a ringing sound. Suppose when there is a delamination, then we put a drum like this, drum like this sound. So that's why you can use this kind of a hammer or a small stick or whatever it may be. Keep on tapping the surface. Then you can find or locate where is the possible locations of the damage. Possible locations of it. Very easily you can find it. You can just go to the this stuff. You can just go to the your residency. Then the roof slab, let us say. You take a small stick and try to impact. Try to use impacting with a stick on the surface at several positions. And try to observe the sound. Whenever there is a change in the sound pattern, then you can definitely suspect certain kind of damage in that particular portion. So you can see for yourself actually. You can you feel that. And another technique is chain dragging techniques. What is the advantage of this chain dragging technique, or what is the disadvantage of the previous technique, that is hammer sounding technique? This is a point specific. Sounding is a point specific. Actually. Suppose if you are asked to inspect the very large slab, then you cannot use this hammer sounding technique because it takes a lot of time. So that is why what they do is they will take a chain, an iron chain like this. They keep on dragging the chain, okay, over the surface. But while dragging, what you have to do is, while dragging, you have to keep you have to keep listening to the sound that emanates. Whenever there is a sound change is there because of the movement of this chain dragging, then you just mark that particular area and go for the further destination. So this is a chain dragging techniques, which is a simple technique which will allow us to find particularly the delaminations, particular delaminations of these surfaces, okay, particularly concrete surface. This is also very simple technique, doesn't cost much. Then coming to the instrumentation part, there are as simple as rebound hammer. This I think, I hope all of you might have experienced this kind of a technique in the laboratory or in the field also. This is a very simple technique. It's a hammer, rebound hammer technique. What is the principle behind this rebound hammer is the hardness of the surface. Hardness of the surface. If the higher hardness is there, it shows higher rebound hammer. If the lower hardness is there, a lower rebound hammer. Like suppose, for example, if you throw a ball onto the hard surface, it rebounds to a higher extent. Suppose if you throw the same ball onto the mud, it will not rebound at all. It doesn't show any rebound thing. So that is why this particular technique is based on hardness of the surface. So whenever you can see this particular figure, when you press this rebound hammer against the surface, there is this latch gets released, and this hammer is released because of that. Whenever that hammer rebounds back, it takes this needle to or an indicator. We call that as an indicator. Actually, indicated to a specific number. Okay. It stops here. Then we can assess the rebound number. This is called rebound number actually, but normally it is calibrated with the strength. So a particular rebound number will have a expected strength of the compression strength. So there is a code of practice. So you can see the code of practice as per ASTM it is C805. As per IS it is 13311 part 2. That code you can use. So this is a kind of a technique wherein easily you can find the strength of the concrete. But you should have the calibration chart. Unless you have a calibration chart, you cannot find the strength. Okay. But this can be used as a comparison between different concrete surfaces. which concrete surface is more harder, etc. But here there is a small problem with the rebound angle. What happens is whenever the plunger, if it happens to be on aggregate which is very near to the surface, then definitely it gives a higher rebound number, and which may lead to the wrong misleading results also. Okay, that's why you should have a number of points. You have to take these rebound numbers, then take the average of this. Okay. Sometimes what happens whenever there is a carbonation makes the concrete surface harder. Carbonated concrete is very harder actually. Okay. Then whenever there is a carbonated surface is there, that also gives a higher strength. It also misleads the concrete strength actually. So that is why you should use, there is a subjectivity involved in this kind of a testing. You should use with experience what is the condition of that particular concrete surface. Then coming to the another method, ultrasonic methods. We have got C597 as per ASTM and IS 13311 part 1. This ultrasonic test, they allow the examination of homogeneity. Suppose coming to the previous test, that is the rebound hammer test, it only depends upon the surface condition. It doesn't say anything about what is the inside status of the structure, whether there is the inside cracking is there, porousness is there, etc. That is nothing is we cannot assess using this rebound hammer. For such things, we go for sonic ultrasonic methods. So the use of this ultrasonic method facilitates the determination of defects within the structure. Then application of these tests are relatively easy to be conducted. Okay, now coming to the ultrasonic methods, you have got here I have taken two types of instruments. I have taken one is the ultrasonic pulse velocity instrument, and another is a tomography, ultrasonic tomography instrument. Okay. Now coming to the ultrasonic pulse velocity, see the ultrasonic pulse velocity. This also you might have used. Most of you might have used this UPV tester in the laboratory. It's a very useful technique. In this, there is a pulse generator is there. Normally, very simple instrument. That instrument consisting of a pulse generator and the transducers. Transducers means there are two transducers. One is a transmitter of these pulses, and another is a receiver of these ultrasonic pulses, which are traveled through the media, concrete media. So you can find out what is the time of travel through the media. Then if you know the distance between these transducers, the distance divided by the time, it will give you the velocity of that particular ultrasonic pulse wave through the media. And if the ultrasonic pulse wave is velocity is very higher, means there are no cracks, no delaminations, no. So that is why entire material is integrity. Integrity of the material is there. That's why velocity of the wave is higher. Whenever there is a inside porousness is there or a concrete cracking is there, then these waves will take a different route to reach the receiver point. So that's why they take a longer time. Longer time to travel the same distance between the transducers will result in a lower velocity. So that is why we can assess what is the condition of the system by knowing the velocity of these pulses. For example, as per 13311, you can see this table. What will be the velocity of the pulse in kilometers per second? So many kilometers per second, actually. 4.5 and above, it is excellent. 3.5, 4.5, good, etc. So these are all the certain norms they have specified. You can use this, and you can also have you can also develop a calibration chart between the pulse velocity and the compression strength. If you have that calibration, then you can use that particular. What should you do for generating such kind of calibration charts? In the laboratory, you will be testing the concrete cubes. So whenever you test a concrete cube, that is a destructive test. Normally, you carry out destructive tests. Whenever you carry out that kind of testing, before the testing, use these two instruments, rebound hammer as well as ultrasonic pulse, and keep a record of them. Such and such is a rebound hammer, such and such is ultrasonic pulse velocity. Then after testing, you will anyhow you will come to know what is the strength. Okay. Then that of strength also you please record it. Then with this data, you can have a calibration chart for the both ultrasonic pulse velocity as well as for the rebound. So such charts you can use whenever you take this instrument to the field. You are going to test a new concrete there. Then whenever you get the ultrasonic pulse velocity there, then you can use this calibration chart that is already developed in the laboratory. Then you can say what is the strength. Otherwise, you cannot say that what is the strength. Okay. Unless you have a calibration chart, you cannot say the strength. This instrument doesn't give the strength actually. Okay. Now coming to the this is ultrasonic pulse velocity test. Here the one particular requirement is you see the placement of these transducers. One is kept on the one side, another is kept on the other side of the concrete cube or whatever. So that means you need to access the other side of the concrete in order to have a proper signal of this proper measurement of ultrasonic pulse velocity. Of course, you can also measure the pulse velocities by keeping the transducers on the surface, both transducers on the same face, but it gives a less accuracy of those kind of pulse velocity readings. So you need to have better reading is done whenever these transducers are on the opposite faces. So definitely you need to access the other face in order to assess the properly the status of this ultrasonic pulse, status of the concrete. But in some situations, you cannot assess the other part of this system. For example, pavement is there. For example, pavement. Suppose the pavement is already laid. How do you test ultrasonic pulse velocity? You have to put the pulse transducers only on the top surface. You cannot go to the bottom of the pavement and you cannot put the transducer. So there is a restriction. So in such case, we need to assess the system. We need to assess the condition of the system by assessing the recordings only from one side, one face. So in such case, we use the tomography techniques, ultrasonic tomography techniques. So this technique requires access to one side of the object. Particularly, this is very, very useful in the case of pavements. This tomography techniques. So in this, you are seeing the instrument. This instrument, bottom of the instrument is like this. There is a 40 transmitting and receiving probes. Each probe is transmits the signal as well as receives the signal also. As well as receives the signal also. So this is a tomography instrument. Here, what is that we do is this particular instrument produces a small force, oscillating force over a small contact zone. That's called we call this a dry point contact, DPC contact. Okay. And transfer this force signals, ultrasonic signals in the form of ultrasonic waves. They travel through the medium whenever they encounter a dissimilar media and they revert back. Then time of travel. From the time of travel, we can know the location of the damage. You can see this is a kind of images that we get. For example, here the signal goes whenever they encounter dissimilar kind of materials, and they try to repulse them, reflect it back actually. So using this, the image will be in the form of, in the form of figures, in the form of images, colored images. Here, ultrasonic tomography that can be used for different types of scanning the particular concrete. beams or whatever. There is a different scanning systems. One is a D scan, B scan, C scan, like that. D scan is the only point kind of a, assessing the condition, whereas the B scanning is a two-dimensional assessment. C scanning is three-dimensional. That means depth also, location of the defect also we can know this. So you can see the images. For example, in case of a tiled surfaces, if you see, this you say whenever there is a hollow delamination of the tile, indicates in the form of image like this. For example, concrete pole, it is tested. It is showing the reinforcement, presence of the reinforcement. So it can be scanned. The entire structure can be scanned using this tomography. You can see different images using the ultrasonic tomography. Entire bridge span is scanned. They are finding there are certain zones with different colors. That means there is a delamination has taken place. Then they go for a particular detailed investigation in those zones. So this is the ultrasonic tomographic image of the different parts of a cube or a cylinder, etc. So you can see honeycomb structure image will be like this: debonded tile or ungrouted duct in the slab. It's a solid wall section, perfectly bonded tile. It shows like this. So whatever it may be, the interpretation of these images requires a certain kind of experience. That is when there is a lot of subjectivities that is involved in this tomography test. However, this is a very useful technique. There is one small instrument, sometimes it is very useful. Ultrasonic thickness gauge. It's a very simple instrument. This sends ultrasonic signals through material, and those signals will revert back whenever there is a changes material. Then we can know what is the thickness of this. For example, particularly this particular instrument is very helpful, wherein you cannot access the other part of the structure. For example, large cylindrical storage tanks. For example, you might have seen large petrol tanks, storage tanks, very large storage tanks. So from the surface itself, you can assess what is the thickness of that cylindrical shell. You need not go to the inside of the cylindrical shell to know the thickness. Why there is such kind of thickness measurements are required is whenever such tanks, whenever they are used for the storage of hazardous materials, in due course of time there will be damage to the material and thickness may get reduced. So if you do not assess the reduction in the thickness, there will be sudden failure of those storage tanks. So that is why periodically they inspect the thickness of the cylindrical storage tanks at different locations. Find what is the average thickness. So for such applications, actually, this instrument is very low cost instrument actually, but very useful instrument. Okay. Now coming to another problem in concrete, particularly reinforced concrete, corrosion. You all know what is corrosion. Okay. This corrosion, what happens? The corrosion of the reinforcement expands. I mean, not expands. So what happens? It increases its volume by more than 2 times almost. So that is why whatever be the concrete strength, if the reinforcement is corroded, then it disturbs the concrete, surrounding concrete. So that's a very, it's a dangerous things. If corrosion is unabated, then it leads to the failure of the structures. So to assess this corrosion in reinforced concrete, you have different instruments are there. Here I have taken 3 such types of instruments. One is half-cell potentiometer. Another is a Galois pulse. Then another is a resistivity, concrete resistivity. This is half cell potentiometer as per the ASTM C87691. So practice, you can use it. Okay. It's a very useful instrument. It's a very simple instrument. Here, there is not much instrumentation, only voltmeter, wherein you can measure the voltage. That's a simple voltmeter. This voltmeter, these two leads, okay. One lead is connected to the electrode. That electrode can be copper electrode or silver nitrate electrode. This is an electrode which can be placed on the concrete surface at any point. Then another lead, which is from this voltmeter, is connected to the rebar. That's why in this kind of testing, a small destruction will be there. That means you need to make a small hole in the concrete reinforced concrete system. You need to expose the reinforcement, and a little bit of reinforcement exposition is required. And this lead is attached to the reinforcement bar. One lead is attached to the reinforcement bar. Then other electrode, which can be moved on the surface. So what it measures the potential difference between these two locations. Depending upon potential difference, then we can assess what is the corrosion. Okay. So this is a very useful instrument. So within this, you can also scan what is the potential difference at different locations of the concrete slab or bridge deck, anything. So it records the millivolts, so much is the potential difference. Then you can have a contouring map also. Contouring map also you can. So you can see some helpful chart. For example, potential difference in millivolts, it is 0 to minus 200, greater than 90% probability of no corrosion. The potential difference is minus 200 to minus 350. Corrosion is uncertain. Suppose the potential difference is less than, that is minus 350, then greater than 90% probability that corrosion is certain. If there is positive value means there is certain defect is there, moisture content is not proper to assess the potential difference. That's why there is need to wet the surface. Okay. Yeah, you can see here how they are measuring here. One lead is attached to the reinforcement, another electrode can be moved on the concrete surface anywhere. Gives the potential difference between this point, wherein the lead is attached to the reinforcement, and another point, concrete. So here you have got that electrode. You have got two types of electrodes: copper sulfate electrode, and silver chloride electrode. Each has different measuring things, actually, measuring values. So you have to go by that and to assess what is the presence of the corrosion. Yeah, that's this half cell potentiometer is also affected by certain kind of situation, wherein degree of humidity, which will affect the results. Sometimes stray currents will also affect the presence of the results. Then oxygen content near the reinforcement will also affect these results. So that's why this also needs certain experience to assess the results. Now coming to the Galva pulse, this is also another handheld instrument. This Galva pulse system, this is typically used for scanning the surface, concrete surfaces of swimming pools, bridges, balconies, parkings, lots, etc. It's a rapid kind of instrument. It's a non-destructive polarization technique. Principally the polarization technique. Okay. Now here you can see the principle of this particular instrument. This is a reference electrode. Actually. Reference electrode. Here a small current pulse is imposed on the reinforcement. There is a counter electrode is placed on the concrete surface that will, and there will be guard ring will also be there that confines this current to a certain area. So this instrument measures what is the polarization resistance of the reinforcement. depending upon the polarization resistance, corrosion rate can be calculated. Corrosion rate is 11.6 times the corrosion polarization resistance divided by the area. Okay, so that gives the polarization resistance. Which depending upon that, we can assess the corrosion rate. For example, corrosion, the polarization resistance is 0.5 microamperes per centimeter square. Corrosion rate is negligible. Between 0.5 to 5 microamperes per centimeter square. Then it is like that. There are certain guidelines are there. You can assess using those guidelines is corrosion rate. Then another handheld instrument is a resistivity meter. A resistivity meter looks like this. It's a very small handheld instrument. It has got four probes. Okay, four probes are there. Two are external probes and two are internal probes, intermediate probes. So one is the pulse generator, then another is the receiver line. So in this resistivity, we are going to measure the normal electrical resistivity of the system. Depending upon the electrical resistivity, one can assess the corrosion of the system. Okay. So this is a kind of handheld instrument. It is held like this. Then it measures the electrical resistance. Less than 5 kilo ohms per centimeters, then very high is a possible corrosion rate of reinforcing bars. If it is greater than 20, insignificant is a corrosion rate. Like that, this corrosion resistivity meter we can use to assess the corrosion. So we have discussed three instruments. One is the half cell potentiometer, another is galva pulse, another is a resistivity meter. These are the three instruments which we can use successfully in the determination of the corrosion in the RC systems. Anyway, okay. Then coming to the acoustic emission technique. This is a very useful technique for testing large structures, particularly bridge structures. Acoustic emissions technique. The principle is very, very simple here. Any structure for that matter, any structure, if that structure or any material, say any material, if it is stressed means if it is loaded means we are applying some stress. Some stress is induced with that. Whenever it is stress is induced, it emits a noise. It emits the noise. For example, if you sit on a branch of a tree, let us say, it gives some creaking sound. Or if you sit on a old chair or a wooden table, it gives a small sound, creaking sound. What happens whenever you apply load, the material experiences stresses, and those stress waves are released. Stress waves are released in the form of an acoustic sound waves. Stress waves are released in the form of an acoustic. Okay, this is a very simple technique. But sometimes we hear the sound, sometimes we don't hear the sound. Okay, suppose if you place a small load on the concrete beam, you don't hear any sound actually. But there are certain sensors, acoustic emission sensors, they can hear these sounds which are beyond this audible range. If the sound signals are beyond audible range, we will not be able to hear that. But the instruments can hear and record the number of sounds. This is called acoustic emission technique. Here also, similar to your ultrasonic pulse velocity, you have got the probes will be there and sensors. So they try to assess what is the number of sounds or number of, we call that as number of hits actually. Number of sounds is called the number of hits actually. They record number of hits. So how this technique is used actually? Now you can see in this figure, for example, a large bridge structure is there. What they do is they keep a known truck load, let us say, some 20 tons truck load, 25 tons truck load, like that, at certain position. Okay. Then they put these acoustic emission sensors at different parts of the bridge. Then they try to assess the number of sounds that are emanating because of the load. Because the load has created a stress used in the system. The stress waves are released in the form of sound. Those number of hits are recorded. Then what happens? As soon as you record the number of hits, you cannot say anything. It requires continuous monitoring. After certain time, for example, let us say 1 month or 2 months, again the same truck load is placed at the same location, and you try to again get the number of sounds. So number of sounds should be equal to the previous number of sounds, previous number of hits. If such is the case, then there is no damage. There is no damage in the system. Okay. Suppose when there is a difference in the number of sounds, then we can have it. Hello. Now let us see. So whenever there is a number of sounds is increasing, the stress waves are increasing, then we can suspect certain damage in those locations. This is a very useful technique, acoustic emission technique, very simple technique. So for that matter, any non-destructive equipment, the principle is very simple. We use those known principles of physics, then we try to apply them there, try to assess the condition of the structure. Yeah, there is another kind of a test. Windsor probe test. Windsor probe. Now this is a very simple. This is also handheld. Here, this Windsor probe consisting of a power activated driver. Power activated driver means there is some kind of a probes. Probes means we call that as the bullets, but these bullets are little bit longer actually, like this. These these probes, and they are inserted into this Windsor probe, and you place this Windsor probe against a surface and charge this. Then this particular probe tries to penetrate into the system. So what happens when the concrete system is weak, strength is weak, this probe penetrates to a greater extent. Whenever the concrete system is higher strength, this probe will not penetrate higher, it penetrates less only. So that means here we try to see what is this unpenetrated depth. If unpenetrated depth is more, means system is strong. The unpenetrated depth is less, means the entire probe has gone inside. Then the system is lesser strong. So this is a very simple instrument, but here it involves small kind of a destruction. It's not completely non-destructive. However, it is considered non-destructively, but there is a small disturbance to the concrete surface. Actually. Okay. So this is what Windsor probe test. Here you can see the graph. The exposed probe length, that is unpenetrated probe length. If it is higher, means higher strength. If it is lesser, means lesser strength. This is a calibration chart. You can see the calibration chart here. This is a very simple instrument. This can be used as a continuous monitoring. For example, you cast a cube, let us say. Cast a cube and try to use this Windsor probe test on this cube at different days of curing. Let us say 3 days of curing and 7 days of curing. Let us say 15 days of curing, 14 days, 21 days, like that. As the number of days increases, this probe tries to, it penetrates less into the system. That means as the concrete is getting stronger, gaining strength, then it doesn't allow this probe to penetrate. Okay. It's a very useful instrument. Okay. Then another pull-out test. This also, we cannot say completely non-destructive. This is also a little bit of semi-destructive test. Okay. So in this pull-out test, what is that we do? We are going to insert a steel insert, a small kind of a steel insert is placed while casting the system, whether it is a slab or a beam or whatever it may be. We put the steel insert while casting itself. Then once the concrete is hard, then try to pull that particular insert using this pull-out instrument. Okay. So when you require more pull-out force, then it automatically indicates the higher is the contact strength. When you require less pull-out for pulling out this particular insert, it indicates lesser strength. So there are the calibration charts are there, which will help us what is the concrete strength pull-out test. Yeah, coming to the infrared thermometer, this is also very useful testing system to assess the concrete surfaces. This infrared thermography, it basically depends upon the surface temperature. Any material which is above this absolute temperature range, it emits the signals. It emits the signals. So this is the technique which depends upon electromagnetic radiation. This electromagnetic radiation depends upon object temperature. Okay. The electromagnetic radiation is recorded in the form of image. So this is called infrared thermometer. It is very useful. So infrared thermography, you can see this particular spectrum, light spectrum. See, whenever there is a long wavelength is there, the less frequency, low frequency will be there, etc. Whenever there is short wavelength, there is high frequency. We are going to use the infrared range in this particular system. So what happens? It is depending upon the object temperature, the image will show. The image will show. Here in this, you can see the image of a, let us say, cat. Suppose if you take a picture of a thermographic picture of a cat, you will find like this. The cat, wherever the hot spots are there, it shows up thick colors actually. For example, a building. If you take the image of building, it shows a thermographic image. For example, this is some kind of a space shuttle, which is while entering into that, it nose as well as the tail part. They are subjected to very high temperatures. This thermographic image of, for example, here you can see a person which is who is holding a snake in his hand. Actually, snake is a cold-blooded animal, whereas our body is a hot blood. Okay. So our temperature is higher than the snake body temperatures. So that is why you can see clear distinction between the hand as well as the snake. Okay. So this is thermographic image of that particular incident. Okay. So using this, we can present the locations of the damage. For example, here for a comparison, there is a normal picture is there and the infrared picture is also there, thermographic image is also there for the same location. This is a normal photograph. This is the infrared. So you can see a normal picture, you don't find any differentiation in the tile roof. Whereas a thermographic image, you will find there is a color change within this system. Similarly, you can see the structural glazing. Also, normal picture is there, thermographic. So there is a color difference is there in certain part of the glazing. That means that shows there is some problem with that, or that the temperatures are less, etc. You can go to the near to that and inspect further. This is a corner of a room wherein there is a moisture ingress. Whenever there is a moisture ingress, there is a temperature which will be less. So you find out difference in color image, thermographic image. You can presence, you can identify the presence of moisture within the structure. So there are all different pictures. Yeah, these are also different types. Particularly this thermography is very, very useful in case of fires, fire accidents. Whenever a building got fire and whenever the fire is extinguished, even after 2-3 days, even if you go there and take the picture of the using thermography, you will find the locations where the temperature was high actually. Similarly, if somebody is unconscious, 1 minute. Hello? Hello? Hello?
Yes, it's audible.
Yes, I'll close another 2-3 minutes. Okay. Right. Yeah, that's right. I think we'll try to close this. These are so this the kind of suppose whenever somebody is unconscious in the case of smoke, in case of fire accidents, you can take a picture of with the thermographic camera. You cannot see with your eyes because there is all together smoke is there. You cannot find anything. But this thermographic camera that can take the picture of the human body because of the heat difference, temperature differences, you'll find where this person is unconscious, etc. You can go and rescue the person. Okay, like this, there are different types of instruments are there. Similarly, concrete carbonation. Concrete carbonation results in the lessening the pH of the system, which results in the erosion once again. You can find the presence of the concrete carbonation using this phenolphthalein indicators. It's a very simple technique. Similarly, cover meters are there, which will help us in finding the location of this diameter, the cover thickness, etc. Then there are imaging techniques are there, ground penetrating radar, radiography, X-ray techniques. Okay, so this kind of things we nowadays people are using it for better assessment of the system health. Okay, this entity impact eco instruments are being used. Like this, there are several things are there. Okay, so I'll now stop here. Any questions? I'd like to. Yeah, Professor Satish. Hello.
Sir.
Yes, yeah. This I'm concluding my presentation. Okay. Any questions? Yeah, please. Yes.
Any questions, please ask to sir. Hello, participants.
Okay, I'm stopping my sharing. I mean these slides.
Sir, thank you very much, sir. Thank you.
Okay, thank you.
Thank you, sir.
Thank you, and I thank the organizers for giving me this opportunity to interact with you all. Any kind of questions, you can also interact with me through the mail also. Official email ID is there in the website, NIT website. You can contact. Thank you once again.
Thank you very much, sir. Thank you.
Thank you. So, shall I leave?
Yes, sir.
Okay.
Okay,
bye.
sir.
So the next resource person is Dr. A. Mallika. So the session starts in another 10 minutes. Okay. So the participants can have some break and we'll start by 7:35.